Hi there, welcome back to the channel and welcome to a new project, and it's going to be hopefully a short project. This is the restoration of a SABA Transall de Luxe Model E. It's from about 1968. I think they sold it between 68 and 70. And I decided to stay with SABA since I've just finished that really big 9-course meal on the SABA. Hopefully this will be a snack. And SABA, for me, as you probably worked out, is one of my favorite brands. I had never worked on a SABA portable, and this is the first one. I decided to continue with SABA because I had this thing sitting around for some time. Some while ago, I got really excited about these small luxury transistor radios that came out. I've done a couple on this channel. One of them is the Philips. The other one was the Nordmende Transistor. I really like their compact design, the quality. There's certainly there's a nice element to it. I like the feel of them. I like the sound. So I bought quite a lot of them at the time, and I've got quite a few waiting for restorations. And every now and then I pull one out when I want a little bit of a snack, some short project just to enjoy. And this is definitely one of them. I had no idea what this radio was going to be like when I first decided to start the project. I've managed to get all the servicing information, and it's pretty complete. There's a lot of information on it, so that's not the issue. The problem was the difficulty of actually servicing this thing. I had no idea just how unservice friendly this thing was till I started working on it. But anyway, this first video takes me through to getting the radio completely working and starting some of the cleanup procedure. And I'll be needing another video to do alignments and adjustments and fix the cabinet and so on. So if this sort of thing excites you, stick around and enjoy the video. But before I carry on, I just want to thank the sponsors of this video, PCBWay. You'll find them at PCBWay.com. They are the people I use for all the PC boards that I make on the channel. Incredible price, really fast turnaround time. And besides PCB, they've got an enormous amount of other services. CNC machining, 3D printing, sheet metal, injection molding, whatever you need, they've got. And they're actually running a promotion right now on PCB assembly services, which means you can get your project really one step further, either turnkey using the PCBWay supply parts or a customer supply parts, or you can have a combo of that as well. And they'll describe to you how it works. It's very, very simple. You'll get a full quote on your project by setting the required parameters, describing to them exactly what options you want on the boards, add a PCB order to the order itself, and then you push calculate, and it'll give you the final result. This is obviously just a sample to show you how it works. So if you have a project in mind and you want somebody else to do the carrying, go ahead, check them out, and get your assembly done with PCBWay. Let's carry on now. There's a saying that goes, man cannot live from bread alone. And in the restoration world, the same saying applies when it comes to the dimension of your projects. We cannot live from restoring massive SABAs, massive GRUNDIGs, massive TELEFUNKENs alone. Those are all hefty meals, and sometimes you need a snack to aid with digestion. And I needed a break. I needed a break from big projects, and I decided to stick to the same brand. This is a SABA, and it's from 1968 to 70. I believe this is when this was done or sold. And it is a SABA Transall Automatic Model E. Now, it's got quite a few nice features, but let's quickly look at the body first. There are a few little dings and, well, cutouts that I'm going to have to sort out somehow. The front looks okay. There's a little bit of an indentation here, which I'm sure I can get out. No big problem. So this front needs some polishing, some cleaning. It seems to be fine. On the side here, we've got the headphone, external speaker, or what is that, tape? And there's a tape and pickup input here, so external auxiliary input, which is great. On this side, there's nothing, one screw. And we can see that this thing needs to be bent back. That shouldn't be too much of a challenge. Now the back all seems fine with one glaring exception, and that's that guy over there. Now I don't know, but I presume this thing came with a proprietary socket for the mains, and someone decided to put this figure 8 type in here and did a really crappy job of it. They hacked this part off, they put this thing in skew. Really not a good job, so I'm going to have to do something about it, and I really don't know what to do right now, but I'm sure something will come up. I'll try and think like Dave Tipton and see what he would do, and away we'll go. Now, all these marks I'm sure can come out. Some of it actually looks like it's been melted, but we'll see. We'll see how we get along. What's the underside like? It looks pretty clean. There's all the screws are in place. Yeah. And as these radios from the era were sold to connect your car, this has got a socket here. It's 1, 2, 3, 4, 5, 6, and 8 pins. And this would sort of plug into a positive, a male socket in your car. And that would connect it to the battery and antenna. And I believe this thing's actually got an antenna motor as well, which is interesting. But that's what we have here. Let's open this up and see if there's any battery leakage in there. Just push that in. Oh, promising. Very promising. I don't see any damage. There are signs of rust, but it doesn't seem to be leaked batteries, which is a good thing. There's our model there. It's a Model E. So the next thing to do is to try and power it up and see if it works. I've connected 7.5 volts, that's what the battery voltage is, to the actual battery connectors there. I don't want to risk damaging this with the external supply, especially with that crazy socket over there. So let's put this on FM and... Oh, okay, I hear some noise. One antenna is missing over here. It's fading. So obviously there are capacitor issues down there as well. Let me try pull the antenna out further. It is reacting to the antenna. Now let's see what this thing's got. It's got preset stations. Oh, something's happening. I can presumably tune here. It's trying to pick up. What happens here is you push the preset and you can tune the preset. Oh. Oh, that's not good. So it looks like something's working. This, I presume, is for the dial. Yes. It's trying to work. Let's see what happens with the other bands. Medium wave, ominously quiet. Some noise, but definitely not much. And I don't think I want to damage this any further if it's got leaky caps in there. Now, what else have we got here? Well, let me show you a little bit of a close-up. Put that antenna back before it snaps. We've got, well, the bands. We've got FM, shortwave, the 49 meter band, shortwave, long wave, medium wave, and Europa. I don't know what that means. What is Europa? Band Europa. What the heck does that mean? Oh, I see. I see. There's the shortwave, rather the FM, from 87 to about 105. It's pretty extensive. It's good enough. Then we've got medium wave. Medium wave goes from 520 to 1600. And immediately above that, we've got Europa, which goes from 1380 to 1600. So this was the second broadcast band, more specific to Europe, I presume. Then we've got long wave going from 150 to 350 or 400. We've got the 49 meter band, which is what is it? It's from 5.95, so it'll be about 5.5 to 6.3, okay? And then we've got the shortwave band, which goes from 6.3 or whatever, all the way up to 16 meters, 17 megahertz. Okay, so it's fairly extensive. Those are the bands. As for the controls, we've got sender, which is tuning. And if I push FM, it moves the top one. So there's some sort of gearing going on here. The same tuner applies to shortwave, to the AM bands and to FM. We've got on-off, we've seen that. And there's an indicator there that sort of shows you that it's on. Actually, this is probably, should be like that when it's off, and it should be red when it's on. So this is obviously shifted. We've got high. This is the Hohen, which is the high frequencies. Tiefen, I think, is the low frequencies. Make sure these are not pull-out of any sort. And then, of course, we've got the 1, 2, 3 tunable presets. And this is actually quite neat, because what you do is you set it, say, to 3, and you can tune it. And if we look closely, that thing's going up the band. That indicator's going up. So you tune it to a preset station, and it stays there. You tune this one to another one, this to another one. And when you want to do a free range dial up of your frequency, you push that one. Automatic, I presume, is... What is automatic? I don't know. There's a strength meter over there. Right, I'm going to open this up and see exactly what it is that we're facing. Now, this thing has got quite a comprehensive service manual. I was actually quite surprised at the quality of this manual. It's very clear, so it's going to be very useful. We've got all the indications here of what things are. Just by the way, what is that auto? It doesn't show. But anyway, we go down, let's see. Oh, we've got German, English, and French. That's brilliant. Okay, so everything's in 3 languages, which makes life a lot easier for us. Power supply, 5 batteries, okay, or the 6 12-volt car battery with car mounting bracket, or mains. We've seen that. All the semiconductors are germanium. No, there's a BC109, which is silicon, but I think most of these are germanium. Dial lamps, fuses, tune circuits. Let's see, there's a wave range, 87 to 104 megahertz on FM with pre-select. Okay, shortwave 6.8 to 18. The 49 meter band goes from 5.9 to 6.24. Broadcast, long wave. It doesn't mention the Europa here. Interesting. Okay, there the IF frequencies, 10.7 for FM and 460 for AM. That's fairly normal. The rod antenna on shortwave, medium, long wave, 2 telescopic antennas. Rod antenna on shortwave, that's a little unusual. And the output 5 watt peak. Okay, loudspeaker, external loudspeaker, nothing too dramatic here. Car mount, antenna motor. I don't understand what the antenna motor would come in, how that would come in here. Anyway, and that would obviously send the sound to the car loudspeaker as well. And AFC, okay, that's the automatic, I presume. Battery check, magnify. It's got a band spread for shortwave, which is great. Tuning indicator, Okay, what else do we have here? This is the German version of the setup. Yep, and then we come here and we've got the English alignment. And it actually gives us a little jig to build up to, this is basically a dummy antenna, so that we can use a signal generator to align things. What else do we have? It's pretty clear. It's all very, very clear. And German, French. Okay, here are the dial strings. I hope we don't need to worry about those too much. And board layouts. This is brilliant. This has got everything here. Various boards, the main board, and the schematic. Now what I've done is I've taken this schematic and I've saved it as a single PDF so that it's easier to work on, and I've already oriented it the right way. Let me show you. Here it is. This is quite a complex schematic. So this thing's got a lot going on here. What can we deduce from here? We've got our transformers down here. We've got the connection to the car system over here. And yeah, auto antenna. This would be the car system. Going to the battery. Power supply. This is from the mains. There's your battery. It would all get switched in here. Power amplifier. It's got a intercoupling transformer over here. So it's driven by these two transformers. Sort of output transformers. This is interstage. This is the output transformer driving these two 8162s in push-pull. That's all front end stuff. Front end. Yeah, it's pretty. That'd be the FM over here. The antennas over there. So it looks pretty standard, but quite complex for a little radio like this. And that's what makes it a deluxe. All right, I'm going to open it up and we'll see what we're facing. They don't give us instructions on how to take this thing out of the case, but it shouldn't be too difficult. We've got some screws here, and we've got some screws on the underside. I think I'll start with those. This one's almost coming off, and this one just keeps turning. That's odd. Okay, that's coming loose. But this has got to come off. That's not happening. Let's try these guys. I'm just trying whatever because I really don't know which order you're supposed to take this out on. I would imagine these guys have to come off. Well, if two come off, the other two have got to come off as well. I think this is definitely the one that needs to come out, and for some reason it's sort of lost its thread. Well folks, that's 1 hour of my life I'm never going to get back. This thing was incredibly difficult to remove. The screw was just turning around and around. I tried to drill it out, and of course the problem with drilling it out is when you put the drill there, it turns as well. So I had to hold it, and I finally drilled it out. And I faced this screw, which is completely loose in there. I'll have to find out how to remove that. And also, I can now see the mess they've got here with wires and God, what a mess. Anyway, this is just the mains coming in. I'll find a better way of doing it there. And then, of course, I've got to repair this damage that was done here. But one thing at a time. I've got the back off. Now I can just remove this whole thing out of here. And there is like a socket and plug over here, which comes out quite easily. I'm not sure if this is original, but we'll find out soon enough. But I've got the back off. Or rather, I've got the bottom off. We can see the underside, and I think that this just pushes out and up. Now that should have been easy. It should have been just two screws on here, remove the top after removing the knobs, and the thing should come up. Let's see if we can do that now. Oh, and of course there are the two screws on the side there, but this should just come out and up. Actually, it comes out the other way. How would I guess that? Okay. Whoa, bloody hell, finally, this thing is out of here. That was a lot tougher than I thought. Definitely a lot tougher than I expected. Just having a quick look here. This thing's not going to stand like this by itself, so I've got to be careful. And this is what we're looking at. A lot of small wires coming from the rod antenna here, so I've got to be fairly careful. There's the antenna holder. A lot of little wires. A lot of little wires. You've got to be so careful because these things just rip out at the slightest bit of pressure. Okay. We've got what looks like the two, here it is, 8162. Those are the two output transistors on there. So that's obviously the power amplifier board. How do I get this out of here? This whole thing has got to be removed. This is definitely not very user-friendly or service-friendly. Bloody hell. This is a bit of a nightmare. Well, did I say a snack in the middle of main meals? This looks like a main meal in itself. Sheesh. Trying to figure out the best way to get into this thing. You see, I can't get to any components here. I don't see any capacitors. I don't see anything really. I'll have to remove this board. Oh God, and that means all these wires have to be desoldered. This does not look like fun. There's a wire that's been cut off here. Well, time to have a closer look at this thing and see how I'm going to get to it. I've got to get to some of the capacitors, see if I can replace electrolytics. I know there's some on here. This is where the power transformer is, and that's where the main supply is, and fuse. So that's fairly easy. I mean, you just remove that. But I doubt very, very much that that's the only problem this thing's got. So I'm going to have to do some close inspection of this thing. Someone really, really messed this up. Well, it's all been redone. As you can see, I've changed the capacitors. There are two capacitors in here, 1000 microfarads and a 50 microfarad. And there was a Zener there. The Zener's fine. And there was a problem. The transistor in here, there's a pass transistor, which I'll show you in the schematic in a minute. That had one leg completely broken off. See that? That's an AC117V, two legs, and the third one is broken off. And the third one is actually the emitter where the regulated voltage comes from. So I thought, well, where the hell did they get this from? I thought maybe the case was connected internally, but it's not. So I checked the voltage, and guess what? They had connected the line that goes to the radio, that orange one or red one. They'd connected it to the capacitor there. Now, the positive of the capacitor is actually the first regulated voltage from the rectifier. So I measured 13 volts. This thing's supposed to produce about 7.5, 7.6. This thing was sending 13 volts to the radio. So not surprising, things were a little bit strange there. Anyway, I replaced the capacitor, the transistor, and I wired everything up again. And what else have I done? Oh, because they replaced this connector has a switch the proprietary connector had a switch so that when you plug in the mains, it breaks a switch that is the battery connection, so that you wouldn't ever get a main supply and a battery connection going together in parallel. Now that's a problem because they removed this and they just shorted everything out. If they had connected mains and battery, you would have had some fireworks on the battery. So what I decided to do is I had to make this a bit safer and I had to correct it. So I corrected first the transistor and get the regulator working so that we can actually send the required 7.5 volts to the radio. And also one other thing, the positive is sort of ground at this point, and they regulate the negative side of the supply. So the pass transistor is a PNP germanium, and it is regulating at the negative end and not at the positive end. It seems a bit strange, but it's the same thing. Ultimately, what you've got is you've got 7.5 volts coming to here, plus and minus. You've got mains switching going through there. The actual mains goes into here, into the radio, goes to the switch, comes back. So this is a main switch in here as well, so you've got to be careful. They have made it separated there, but I rewired this. I put new wires on here. And what else do they have? And I then had to think about what to do about this guy here. And I decided the best way to cover up the hole they'd made on that, on the back of the cabinet, was to put a bigger IEC connector. And this works well. What I've done is I've made that bigger there. And as you can see, it fits in there and you can screw them in. But you don't screw them in here. You actually put it in first and then you screw it through the cabinet. Let me show you. So here's our cabinet. This would go in like this. When the cabinet goes in, this would lift a little bit. Well, you try not to pinch your connectors here when you do that. That would help. So this would go in like that. And then that gets screwed in there. So it holds it nicely onto the, and it covers the top. So you see we've basically covered most of it. The only part that's still showing is this little bit at the bottom, and I'll have to think about what to do there. But I think I've done a pretty good job here. I think this will cover it up nicely, and it also will hold this in place through this backboard and then into that bottom section where I've drilled the holes. So I'm happy with that. Now let me show you what the result is. Now we're going to do something dangerous, which I would advise you not to do. We're going to measure what the result is, and I'll connect the multimeter to the red and black over there. So that should give us about 7 point something volts. Remember, this is no load. Okay, that's fine as it is. One more thing we need to do is we need to switch this circuit on. So we need to short these guys over here. This is acting as a switch internally on the radio, so we short that out. Keep everything out of the way because this thing's going to have mains on here. Now I connect a plug onto here and make sure it's not touching anything. I've plugged it in, and let me switch it on and see what happens. 8.2. Okay, it's a bit high. It's actually, it should be about 7.6 or so, 7.7. But remember, totally unloaded, so I'm not surprised. But at least we don't have 13 volts going into the radio now. I'll switch that off before I zap myself. And I think this thing is actually pretty good. I've cleaned it all up and it's all polished on the underside. Everything is, let me get this out of here. I've unplugged it already over there. So everything has been neatened up. Inside here, what I did was I polished the battery connections. As you can see there, no rust. It was just a little bit of, staining that happened. No big deal. So this is ready to go in. I'm never going to use batteries on this thing, but if somebody does put batteries in here, you won't have fireworks. So that's ready to go. Let me show you what I've done on the schematic. This is the part of the circuit that interests us right now, and what was happening, well, what happens here is the mains comes through the one fuse over there, goes to the mains transformer. That can be wired either as 220 or 110. It's wired as 220 at the moment, and the other mains connection goes in here, and it doesn't go to the transformer. It actually comes all the way across here, into there, through that socket thingy, and it goes into the radio and onto the on-off switch. So one part of the on-off switch switches that mains on, which then comes back here, there, and supplies mains to our primary. The secondary goes through that rectifier, and the two capacitors there are just to remove some noise. And then we've got minus over there and plus down here. It's starting to look weird already. That's a 1000 microfarad capacitor, but so far there's no mystery. This thing is a normal rectifier. And then we've got a PNP transistor. This is the AC117. And what we've got here is, remember, the bottom is the plus. we've got a Zener diode of 7.5 volts, which is fed or biased by that 47 ohm resistor. So at that point, you're going to have 7.5 volts below the positive. And that voltage there is then transferred across to there with a 0.7 volt drop, is it? No, increase. So that'll be not 0.7, sorry, 0.2 or 0.3, depending on the AC117. But if that's 7.5, that'll be, say, 7.7 or 7.6. And that's the voltage that becomes your ground. So between that point and that point will be your call it 7.5 volts, okay? And the difference in voltage is dissipated across the collector-emitter junction of this transistor. Now, that leg there was completely gone, and what they've done is they've taken this leg here, this point here, and that one, and just wired it directly to that point there. It's just amazing. Really amazing. So, and there's a switch here as well. Now this switch is gone. This switch is actually, as you can see, this dashed line that goes up to the one prong of the mains. So that would be, when you put the mains in, that switch would break. In other words, it would go up to the top, and when you take it off, it would go down to the battery. So these two would never actually be in parallel. They'd be switched between one and the other. So what I've done is I've put a diode on here just to reverse polarity it, so that if someone does put mains and there's battery in there, the current can't flow in. Actually, the diode is on this end. It stops the battery from receiving voltage. All right, and then that goes into here. So we've lost the switch there. That's not a problem. That goes into here, and we measured this point and that point. So that's the positive, that's the negative. That would be called this now 0 volts, and that would be 7.5 volts. So that's working perfectly fine. I replaced that capacitor and that capacitor, and of course that transistor. Okay, now we carry on, and I'm guessing there's a big, see, because I've got a supply over here which isn't filtered, it's filtered through here. This is basically a, what is it, a capacitor multiplier. It's fairly filtered, but there's no filter capacitor per se. I'm sure there's going to be one somewhere up here. So our ground is switched here again. I'm not sure what switch this is. E1. What is E1? Well, there's E. I don't know what that is. Well, never mind. It's a switch of sorts. It is a switch of sorts. That's our on-off switch. That's not a problem. Remember, this then goes out, and it's going to ultimately go back to the connector that fits onto the radio. And that receives 6 or 12 volts. So this would be 6 or 12 volts. The positive would go through there. There's just an inductor there for some filtering. And it goes to the same positive line over here, which goes up here. And the negative, there's the negative of the battery. That comes in here, through there, and then it's either 6 or 12. I don't know how you switch this. But you would switch it somehow, which then becomes the negative. Remember, that's the negative over there, that line. And then what we've got going up is the positive voltage through that switch, and the negative through that switch, whatever that switch is. It then goes up to here. I'm not sure if the negative is actually, oh, it is. I was looking for ground earlier on. There's our negative of the battery, right? Goes up here, goes up here. And I was trying to find out how this point connects to one of those ground, chassis ground, and I found it. If you go along here, you get this resistor over here, and then you get ground. So there's a 47 ohm resistor to ground. It's actually raised from ground. In fact, they tell us there's 0.55 volts over there. So this is obviously for some biasing of sorts. I'm not sure what we're biasing yet. Where would this go? This goes there. This will be biasing that transistor. 0.555 volts. So our ground is not the negative of the battery. Ground is actually slightly lower. Okay, not a problem. But so far, so good. We've solved that mystery over here. And it could also be the reason why our radio was coughing like crazy, because think about it. If you've got capacitors on the circuit over here and you fed them 13 volts instead of 7.5, that's not going to be good for them, because some of these capacitors are actually very close to the tolerance. In the old days, they wouldn't use a 50 volt capacitor when they needed 7.5 volts. And I'd probably do that now. I'd put 25, 35, sometimes even 50 volt capacitor. I'm trying to see here. There's one there. I'm trying to see what other electrolytics we've got here. There's another one there. Supposed to see 4.8 volts, but that's not connected to the supply. But there might be others that are actually straight onto the supply that have just got zapped with more than they were looking for. I know there's some electrolytics because I've seen them on the board, and there's actually one pretty big one, but I'm not sure where that is. Actually, I think the big one is 2500. I think the big one that I've seen on the board is that guy over there. It's got to do with the connector that receives the signal from the radio, from the car radio. Okay, all right, this is looking good. But there are a few more electrolytics. I'll find them. There's 1 microfarad over here. There's 25 microfarads over there. Now these things are like, 10 volt? And they saw 13. Not good. I think I'm going to have electrolytics to replace before I try anything else. All right, I'm glad with progress so far. I'm glad I sorted that out. In this restoration business or hobby, sometimes we're good and sometimes we're lucky. And in this case, I think I've been extremely lucky. I started doing some checking of the capacitors. In fact, I started changing them, the big ones, straight away. And I noticed that the big filter caps that were in the circuit really needed work. They needed replacing because it had to do with the full 13 volts, whatever it was that they'd applied to it. So those definitely needed changing. And then I took one out. Very difficult to take them out, but I did it through the speaker hole here, and I checked it, and it was perfect. I did another one, and it was perfect. So then I started checking the ESRs in circuit of all those that I could reach, and they were all perfect. So this means I changed, 3 resistors, 3 capacitors, and listen to this. It's got good volume, good sound.
Para mitigar esses problemas. Portanto, ontem o que se pretendia era discutir o estado da
I'll try that.
Temos enfrentado nos últimos tempos. E as pessoas o que não entendem é que
So I'm getting all the stations that I'm used to on here. This works well. This thing here is the AFC. Remember, I didn't know what that was, the automatic. And in fact, there's a little window there. When you click it, you see it goes red, goes white or blank. That's the AFC. Okay, got that. So that works perfectly well. And I've discovered that if I put this antenna down, because quite honestly, without a mini whip, I can get very, very little only on here. That's normal, so I'll put that on there. I'll actually try and find a chassis ground point somewhere. And I'm going to show you, let's try shortwave. This is definitely the wrong time of day to try shortwave, but we'll go up to the higher frequencies and see what happens. And of course I can do this. This is the band spread. The antenna is flicking around. You definitely need the antenna, the fine tuning. Let's try that. Nothing here at the moment, not surprising. Medium wave, I'm not sure we'll get anything at this time of day. Not surprised you can't get anything this time of day, never mind. There's our local station. So the result is, it's all working. And there's a battery check. I've just realized, where is it? This one. There's actually a battery check that you can activate on there. And the result is this thing's working pretty well. It's all back to life. It's pretty sensitive, and I can only tell that in the evening, because obviously during the day, yeah, it's not a big deal. So the result was quite easy. Back to FM here. And the sound is pretty good. This is somebody on the phone, so it doesn't sound that great, but the sound is actually pretty good. So I'm happy, and I'll show you the mains power as well. Now if I remove the battery connection, I was using the supply 7.5 volts, and I've got everything disconnected there. I'll just put in the mains and switch it on at this end. Perfect. And just to show you how the AFC works, see that? Pulls it in, takes it out, pulls it in. So that is a brilliant result. And just to take this a little bit further, what I decided to do was to clean up the top. I've cleaned up all the knobs. I've polished the brass, or rather the chrome. And this has come out beautifully. I've tried to polish some of the plastic. There were a few scratches on here and a few paint touch-ups on that white underside, which now become completely invisible. And the result is that it is done. This part is done. Now the rest is a different story. And what I mean by the rest is I want to do the alignment, or some alignment, check the alignments. I want to check the biasing of the output stage. They give you a full description on the service manual on how to do that. They describe how to align the AMIF and the FMIF. I want to make sure that this is in tip-top shape. This thing is not easy to work on, but I think the alignment contacts or points are all fairly accessible. So I want to do that. And more importantly, I want to do the cabinet. The cabinet is a bit of a mess. So I want to get that up to standard, and that should make this radio another success. But for now, I'm just so relieved that I didn't have to actually remove that main board, because that would have been a nightmare. This thing is working very well as is. We'll just see if a little bit of touch up on the alignments makes any difference. The sound is very good. The speaker is in excellent condition. The supply is now working perfectly fine. So I'm fairly happy. And I'm going to take a break for now. And I think one more video will complete this project. So I want to thank you for watching. I hope you've enjoyed that. If you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon or PayPal. Links are in the description below. Thanks for watching. Bye for now, and stay safe.